Good morning, children. In the last class, we have discussed about laws of chemical combination. In that, we have discussed about some laws, that is law of conservation of mass, law of constant proportion, multiple proportion, and Avogadro's law. This class, we are going to discuss about the remaining two laws, followed by some definitions, right? First, let me see the law of reciprocal proportion. This law is given by Richter. Okay, law of reciprocal, one more question. Law of reciprocal proportion is given by Richter. Okay, what this law states? Law of reciprocal proportion states that when two different elements combine separately with the fixed mass of the third element, the ratio of the masses in which they combine, either the same or in simple multiple ratio of the masses in which they combine with each other. Okay, so this is the law of reciprocal proportion. Once again, I'll tell you, law of reciprocal proportion is given by Richter. This law states that if two different elements combine separately with a fixed mass of the third element, the ratio of the masses in which they combine, either the same or in the simple multiple ratio of the masses in which they combine with each other. Okay, look at here. This is carbon atom, this is hydrogen atom, and this is oxygen atom. So carbon atom, when it combines with the hydrogen, carbon when it combines with hydrogen to form the compound CH4. CH4 is nothing but methane. Okay, carbon when it reacts with the hydrogen or when it combines with hydrogen to form methane. Methane is the formula of methane is CH4. Now, carbon when it reacts with oxygen to form the compound carbon dioxide. Okay, carbon when it reacts with oxygen to form the compound carbon dioxide. Now, hydrogen when it reacts with oxygen, what is formed? Water molecule is formed. Okay, so this is a different element. Carbon is a different element, hydrogen is a different element, oxygen is a different element. They combine with other elements to form different compounds like methane, water, and carbon dioxide. Look at this tabular column. This is first one is the serial number, second one compounds, third one combining elements, and next one is combining weight. Okay. So what are the compounds are here? Three compounds. One is methane, another one is water, next one is carbon dioxide. So we have to write the compounds in this column. Next we have to write the combining elements. Two or more elements combines to form compound, isn't it? Compound is composed of two or more different elements, that you know, isn't it? So what are the combining elements in methane? Carbon, when it reacts with hydrogen, it forms methane, isn't it? So the combining elements are carbon as well as hydrogen. Next one, carbon dioxide. What are the combining elements in carbon dioxide? Carbon as well as oxygen, right? Next one is water. Here hydrogen. Next one is oxygen. Clear? Right. Next we can move to combining weight. For this you have to know the atomic mass of that particular element, right? For that purpose only we are using the modern periodic table. Okay. So more than 118 elements are present in the periodic table. So we cannot remember all the atomic masses of this 118. But what are the elements required for us? Those elements atomic mass you should learn. Okay. In your lower classes you might have learned side, top right hand corner side, atomic mass is given. What is the value given here? The value is 12. Okay, so you have to put the 12 here. Next, what you have to do? You have to find the atomic mass of hydrogen. What is the atomic mass of hydrogen? See, the first box is hydrogen. What is the atomic mass is given? 1.001. So you have to put 1. At the same time, what you have to do? How many hydrogen atoms are here? 4 hydrogen atoms are here. But what is the atomic mass of hydrogen? Atomic mass of hydrogen is 1. So 1 into 4, you will be getting 4. Okay, you have to count the number of atoms also. Here, only one carbon atom is present. That is what we put the atomic mass number 12 here. But here, 4 hydrogen atoms are present. So we have to calculate this atom with atomic number. Atomic mass of hydrogen is 1. But 4 hydrogen atoms are there. So 1 into 4, we get 4. Next, in the same manner, we have to calculate for carbon dioxide as well as for water molecule. Next, carbon dioxide. The combining elements are carbon and oxygen that you know. Next, you have to put the atomic mass of carbon. What is the atomic mass of carbon? Just now we saw, isn't it? The atomic mass of carbon is 12. So put 12 here. Next, we have to calculate for oxygen. How many? What is the atomic mass? First, you have to find out the atomic mass of that particular element. So where is oxygen? This is the oxygen element. So what is the atomic mass is given? The atomic mass is 16. Okay. Next, what you have to do? You have to calculate the number of oxygen atoms. How many oxygen atoms are there? 2 oxygen atoms are there. What is the atomic mass of oxygen? It is 16. So 2 into 16, you will be getting 32. Right, children? Good. So next we can calculate for water. Okay, combining elements are hydrogen as well as oxygen. Here we have to find out the atomic mass of hydrogen. Atomic mass of hydrogen is 1. How many hydrogen atoms are here? 2 hydrogen atoms are here, isn't it? So 1 into 2, you will be getting 2. Next, for oxygen, only one oxygen atom is there. So atomic mass of oxygen is 16. You have to put the 16 here. Okay, clear about the standard column, children? Shall we move to the next one? Good. Now, here, hydrogen and oxygen combine with carbon separately. Okay, hydrogen and oxygen combine with the carbon separately to form the compounds methane and carbon dioxide. Right? Once again, I tell you, hydrogen and oxygen combine separately with the carbon to form methane, and oxygen combine separately with carbon to form carbon dioxide. The ratio of the different weights, that is, the ratio of the different weights of hydrogen and oxygen is 4 and 32. Okay, the ratio of the different weights of hydrogen and oxygen is 4 and 32. Combined with the fixed mass of carbon. What is the fixed mass of carbon? The fixed mass of carbon is 12. So we get 4 is to 32. So what is the simple ratio? You will be getting 1 is to 8. Right? Now, hydrogen, when it reacts with oxygen to form water molecule. Right? Here, the different masses of hydrogen and oxygen, as well as if you can say the different weight also. The different weight of hydrogen to that of oxygen is 2 is to 16. So 2 is to 16 means what is the simple ratio? 1 is to 8. Now look at the first ratio and second ratio. Both the ratios are same, isn't it? Hence, law of reciprocal proportion is illustrated. Okay, children. So this is law of reciprocal proportion. So once again, I tell you, first you have to put the tabular column Sidating compounds, combining elements, combining weight. Okay. So two different elements combined separately with the carbon element to form three compounds. One is methane, another one is carbon dioxide, next one is water. Next you have to separate the combining elements from this compound. So what are the combining elements? Carbon and hydrogen are the combining elements in the compound methane. Next carbon and oxygen in carbon dioxide, hydrogen and oxygen in water. Next what you have to do, you have to mention the combining weight. Okay, for that what you want to know, you should know about the atomic mass of that particular element by using the periodic table. But in the examination and the periodic table is not given, children. You have to learn all the important elements, atomic number, mass number, relative atomic mass, everything. Okay. So in this manner you have to calculate. You will get the simple multiple ratio. Both the ratios are same. Hence law of reciprocal proportion is illustrated, and this law is given by Richter. Shall we move to the second one, children? Good. Next we can move to Gay-Lussac's law. Gay-Lussac was a famous French physicist and chemist. He formulated this law, hence we say it's a Gay-Lussac's law. This law, that is Gay-Lussac's law, states that at constant volume, the pressure exerted by a gas, at constant volume, the pressure exerted by a gas is directly proportional to the absolute temperature of the gas. Okay, once again I repeat. Gay-Lussac's law states that at constant volume, the pressure exerted by a gas varies directly with absolute temperature of the gas. Otherwise, in one more definition, the same definition, we can change it like this also. This law states that the pressure exerted by gas is directly proportional to the absolute temperature. If you want to explain this Gay-Lussac's law in simple words, means simple meaning means this law states that when pressure increases, temperature also increases. When temperature increases, pressure also increases, and vice versa. This is the law. Okay. So this law can be mathematically expressed as P is proportional to T. Here P is the pressure exerted by the gas, while T is the absolute temperature. This can also be represented as P1 by T1 is equal to P2 by T2. P1 by T1 is equal to P2 by T2. Right? So P1 is the initial pressure, whereas T1 is the initial temperature. Here P2 is the final pressure, whereas T2 is the final temperature. Example of Gay-Lussac law can be observed in pressure cookers. When the cooker is heated, the pressure exerted inside the container increases. Okay. When the temperature increases, at the same time the pressure also increases inside the container. Hence, it cooks very fastly. Okay, so example we can say the pressure cooker. One more activity we can do for this Gay-Lussac's law at the end of this session. Right, children? So what does Gay-Lussac's law states? Gay-Lussac's law states that at constant volume, the pressure exerted by the gas is directly proportional to the temperature of the gas. Right? Now let me see the relative atomic mass. You know very well an atom is very small. Its absolute mass cannot be determined directly. In the beginning, hydrogen element was chosen as standard and the masses of different elements were compared with it. Later, hydrogen element was replaced by oxygen element. Now, carbon 12 isotope is used to determine the various masses of different elements. Each and every element has different isotopes. So, what is meant by isotopes? It is nothing but atoms which contain one or more species. Okay, atoms which one or more species which is present in the atom are called the isotopes. Isotopes, generally isotopes of an element have same atomic number but different mass number, right? So nowadays carbon 12 isotope is chosen as a standard, and various elements relative atomic masses compared with it. Okay, so relative atomic mass is defined as the ratio between the average mass of its isotopes. Okay, relative atomic mass is defined as the ratio between the average mass of its isotopes to 1/12 part of the mass of carbon 12 atom. It is generally represented by the term AR. AR represents the relative atomic mass. Okay, it is also known as standardized atomic mass, right? So AR represents the relative atomic mass is equal to average mass of the isotopes of the element. Which element we are going to identify? Divided by 1/12 of the mass of one carbon 12 atom gives the relative atomic mass. Okay, so relative atomic mass is equal to average mass of the isotopes of element by 1/12 of mass of one carbon 12 atom. This is called the relative. In this manner, we have to find out the relative atomic mass. Okay, it's a 2-mark question. Right? Shall we move to the next one? Good. Next, we can move to atomic mass unit. Okay, that is AMU. Atomic mass unit. In the bracket AMU mentions atomic mass unit. Okay. Already I told you an atom is very small. An atom is generally measured in atomic mass unit. Okay, an atom, mass of an atom is generally measured in atomic mass unit. Right. So atomic mass unit is 1/12 of the isotopes of one carbon atom. So atomic mass unit is nothing but 1/12 of the carbon 12 atom. This is called the one atomic mass unit, right? Atomic mass unit is generally used to measure the mass of an atom. In the bracket AMU. AMU mentions the atomic mass unit. Atomic mass unit is nothing but the average mass of 1/12 of carbon 12 atom, right? In modern system, this term AMU is not used. Instead of this, we are using the term U. U mentions the unified atomic mass, right? Once again, I tell you, the mass of an atom is measured in atomic mass unit AMU. Okay, atomic mass unit is 1/12 of the carbon 12 isotope. Okay, carbon 12 isotope which contains 12 means it mentions 6 protons as well as 6 neutrons. Right, children? It's the 1-mark question. Now, we can move to gram atomic mass. What is meant by gram atomic mass? The atomic mass of an element, if it is expressed in gram. Okay, if it is expressed in grams, then it is called gram atomic mass. It's a 2-mark question. Once again, I repeat, the atomic mass of an element, if it is expressed in grams, then it is called gram atomic mass. For example, atomic mass of hydrogen. What is the atomic mass of hydrogen? The atomic mass of hydrogen is 1. But here we put 1 gram. How? Because this atomic mass of hydrogen is expressed in gram. That's what we put 1 gram, right? Next one, atomic mass of carbon. So this is carbon element. What is the atomic mass? 12. So, atomic mass of carbon is 12 and it is expressed in gram. So, answer is 12 gram. Next one, atomic mass of nitrogen. Where is the atomic mass? Here, this is the atomic, this is nitrogen element and this is the atomic mass. It's 14. Okay. So, the atomic mass of nitrogen is expressed in gram. So, it is 14 gram. Next one, atomic mass of oxygen. This is oxygen element. The atomic mass of oxygen is 16. This atomic mass of oxygen is expressed in gram. Hence, it is 16 gram. Okay. So, what is meant by gram atomic mass? If the atomic mass of an element is expressed in grams, then it is called gram atomic mass. Right? Good. Next, we can move to gram molecular mass. The molecular mass of a compound, if it is expressed in gram, then it is called gram molecular mass. Once again, I repeat. The molecular mass of a compound is expressed in gram, then it is called gram molecular mass. Okay. For example, gram molecular mass of water is equal to 18 gram. How? First, you have to find out the molecular mass of water. You know very well, hydrogen when it reacts with oxygen to form the molecule water, isn't it? So, you have to calculate the atomic mass of hydrogen as well as atomic mass of oxygen. So, what is the atomic mass of hydrogen? It is 1. Okay. Next, what you have to do? You have to calculate the atomic mass of oxygen. Okay. So, atomic mass of oxygen is 16. How many hydrogen atoms? What is the molecular formula of water? It is H2O, isn't it? H2O. So, 2 hydrogen atoms are there, isn't it? So, 1 into 2, you will be getting 2. So, 18, right? Molecular mass of water is 18 and this molecular mass of water, when it is expressed in gram, then we have to put 18 gram. Understood, children? Once again, I will tell you what is composed of hydrogen and oxygen. Its general formula is H2O. 2 hydrogen atom and 1 oxygen atom. First, you have to calculate the atomic mass of hydrogen. Atomic mass of hydrogen is 1. But how many hydrogen atoms are there? 2. So, 2 into 1, 2. Plus, you have to calculate for oxygen. Its atomic mass is 16. Plus 16, you will be getting 18. Second one, gram molecular mass of carbon dioxide. Carbon, when it reacts with oxygen to form the compound carbon dioxide. So, you have to calculate the atomic mass for carbon as well as for oxygen, isn't it? What is the atomic mass of carbon? So, here, see here, the atomic mass of carbon is 12. Next, for oxygen, atomic mass is 16. How many oxygen atoms are here? 2 oxygen atoms are here. So, 12 into 2, 24. 12 into 2, that is oxygen atomic mass is 16. 2 oxygen atoms are there. So, 16 into 2, 32. Okay. So, if you add these two, you will be getting 44. Right, children? Once again, I will tell you. Molecular mass of carbon dioxide. For carbon, its atomic mass is 12. Oxygen atomic mass is 16. But 2 oxygen atoms are there. So, 2 into 16, 32. If you add these two, you will be getting 44. Right? So, this when it is expressed in gram, then we can say 44 gram. Third one, gram molecular mass of ammonia. Nitrogen, when it reacts with hydrogen to form the compound ammonia. Okay, NH3. Next, we have to calculate for nitrogen. What is the atomic mass of nitrogen? It is 14. Plus, how many hydrogen atoms are there? 3 hydrogen atoms are there. What is the atomic mass of hydrogen? 1. So, 1 into 3, 3. So, if you add this, you will be getting 17. So, molecular mass of ammonia, if it is expressed in gram, then it is called gram molecular mass, that is equal to 17 the last one is gram molecular mass of hydrogen chloride. Okay, hydrogen when it reacts with chlorine to form hydrogen chloride. What is the atomic mass of hydrogen? It is 1. Next, what is the atomic mass of chlorine? This is the atomic mass of chlorine, that is 35.5. Okay, so if you add this one, you will be getting 36.5. When it is expressed in gram, then it is called gram molecular mass of hydrogen chloride. For all these calculations, you should know the atomic mass of the particular element. Then only you can find this, children. Okay, children. Now we can calculate the mass of 2.5 gram atoms of calcium. Okay, so we have to calculate the mass of 2.5 gram atoms of calcium. Atomic mass of calcium, it is already given in the question itself. Okay, the atomic mass of calcium is 40, right? So atomic mass of calcium it is 40. This is given in the question itself, right? So first what we have to do, mass of 2.5 gram atom of calcium, isn't it? So we are going to find out the mass for this 2.5 gram atoms of calcium. For that what we have to do, the given mass into atomic mass of calcium. What is the value given for, what is the mass given here? It is given 2.5 grams. So 2.5 into atomic mass of calcium. Sometimes atomic mass of some elements is given in the question itself. For sometimes we have to find out, children. Okay, so you have to go through that also. So the given mass into atomic mass of calcium. What is the given mass? It is given in the question itself. 2.5 into atomic mass of calcium is 40. This is also given in the question itself. Into 40. If you multiply these two, you will be getting 100 grams. Okay. So this is the answer. Once again I will tell you. The question is, calculate the mass of 2.5 gram atoms of calcium. Atomic mass of calcium is 40. For this, you need to know the mass. Okay, mass is already given. It is given in the question, that is 2.5 gram. Atomic mass of calcium you should know, that is also given in the question. So it is very simple, isn't it? Simple calculation. Given mass into atomic mass of calcium. Given mass is 2.5. Atomic mass of calcium is 40. If you multiply these two, the answer you will be getting is 100 gram, right? Shall we move to the second one? Good. The second one is, calculate the mass of 1.5 gram molecules of water. Okay, calculate the mass of 1.5 gram molecules of water. For first what you have to do, you have to calculate the molecular mass of water, right? So for that what you have to do, what is the formula? Water formula is H2O, isn't it? So 2 hydrogen atoms. Already we saw hydrogen atomic mass is 1. Okay. Also we have to count the number of atoms. Okay. So 2 hydrogen atoms are there. So 2 into 1, 2 plus what is the atomic mass of oxygen? Oxygen atomic mass is 16. Okay. So 2 plus 16. If you add these two, you will be getting 18. Right? So now you know the molecular mass of water. So in this manner you have to calculate the molecular mass of water. Next, 1 gram molecule of water is equal to gram molecular mass of water. Already you know the gram molecular mass of water. So what is the question? We have to calculate the mass of 1.5 gram molecules of water, isn't it? So simple multiplication only. 1.5 gram molecules of water is equal to molecular mass of water. What is the molecular mass of water? It is 80 into, you have to calculate for 1.5 gram molecule, isn't it? So into 1.5, so you will be getting 27 gram. Right, children? Once again I repeat, the question is, calculate the mass of 1.5 1.5 gram molecules of water. So, molecular mass of water we have to find out. Hydrogen and oxygen react to form water. So, what is the atomic mass of hydrogen? It is 1. How many hydrogen atoms are present? 2. So, 1 into 2 will be getting 2. Next, atomic mass of oxygen is 16 plus 16. If you add these two, you will be getting 18. Next, what you have to do? You have to calculate the mass of 1.5 gram molecules of water. So, molecular mass into 1.5 gram molecules of water. If you multiply these two, you will be getting 27 gram, right? Next, we can move to percentage composition. Percentage composition is very important. Percentage composition of a compound is generally used to represent the mass of each element in 100 grams of the compound. Okay. Based on this, we will calculate for water first, H2O. We are going to calculate the percentage composition of water, right? First, mass first we have to use one formula here. See that mass percentage of an element is equal to mass of that element in the compound by molar mass of the compound into 100. This formula we have to use for calculating the percentage composition. Okay, once again I will tell you. Mass percentage of an element is equal to mass of that element in the compound by molar mass of the compound into 100. First, what you have to do? You have to calculate the molar mass of the compound. How to calculate the molar mass? First, what you have to write? Molar mass of water. You are going to calculate for water. H2O is there. So, first step is molar mass of H2O is equal to 2. How many hydrogen atoms are here? 2 hydrogen atoms. What is the atomic mass of hydrogen? It is 1. Plus, because hydrogen and oxygen combines to form water, isn't it? So, plus. Next, what is the atomic mass of oxygen? Atomic mass of oxygen is 16. That is equal to 2 into 1, 2 plus 16. So, you will be getting 18 gram. Now, you know the molar mass of water. Okay. Next step, we have to calculate the mass of that element in the compound. What are the elements are present in H2O? Hydrogen as well as oxygen. 2 elements are present. First, we have to identify for hydrogen. Next, we have to calculate for oxygen. Okay. Next step is mass percentage of hydrogen. Then in the formula it is given now mass percentage of an element. So 2 elements are there. First we are going to calculate for hydrogen. Next we can go for oxygen. So mass percentage of hydrogen that is equal to, okay, for hydrogen how many hydrogen atoms are present here? 2 hydrogen atoms, isn't it? So it is given 2 here. So 2 divided by molar mass. Divided by molar mass. That is mass of that element in the compound. We are going to find out for hydrogen. How many hydrogen atoms are here? 2 hydrogen atoms. So 2 divided by molar mass of the compound. What is the molar mass of water? The molar mass of water is 18 gram. Okay. So 2 divided by 18 into 100. Why? Because we are going to calculate the percentage composition. So you should put into 100. 2 into 100, 200 divided by 18, you will be getting ordinary division. You will be getting 11.11 percentage. Got it, children? For first element, we got the answer. Next, we can go for second element, that is oxygen. The same method we have to use here. Next, mass percentage of oxygen is equal to, what is the atomic mass of oxygen? It is 16. Okay. So 16 divided by molar mass of the compound. What is the molar mass of the compound? It is 18. So 16 divided by 18 into 100. So 16 into 100 you will be getting 1600 divided by 80. You will be getting 88.89 percentage. Now, if you add this 11.11 plus 88.89, you will be getting 100. Okay, so this is the first one. In the same manner, we are going to calculate for one more compound. That is for methane. CH4 is methane. Okay, first, what's the first step? We have to calculate the molar mass of methane, right? So, carbon when it reacts with hydrogen to form the compound methane. So, we have to know the atomic mass of carbon as well as for atomic mass of hydrogen, right? So, molar mass of methane CH4 is equal to, first we have to calculate for carbon, next we have to move for hydrogen. So, what is the atomic mass of carbon? The atomic mass of carbon is 12. Okay. Next, what is the atomic mass of hydrogen? It is 1. How many hydrogen atoms are there? 4 hydrogen atoms. So, plus 4. Okay. So, 12 plus 4, you will be getting 16 grams. Right. So, next, you are calculating for mass. So, you are putting grams. Next, what you have to do? You have to calculate the mass percentage of carbon. Next, you have to calculate the mass percentage of hydrogen. So, mass percentage of carbon is equal to 12. This is the atomic mass of carbon. So, 12 divided by molar mass. Okay, what is the molar mass? It is 16 gram. So, 12 by 16 into 100. 12 into 100, 1200 divided by 16, you will get 75 percentage, right? Next, we have to calculate for hydrogen. So, mass percentage of hydrogen is equal to, how many hydrogen atoms are there? 4 hydrogen atoms. What is the atomic mass of hydrogen? It is 1. So, 1 into 4, 4 divided by, what is the molar mass? It is 16. So, 4 by 16 into 100, that is equal to 400 by 16. You will be getting 25 percentage. If you add 75 percentage as well as 25 percentage, you know very well you will get 100. So, in this manner, we have to calculate the percentage composition for this. For that, you should know the formula. Okay, you should know this formula. That is mass percentage of an element is equal to mass of that element in the compound divided by molar mass of the compound into 100. First of all, you should calculate the molar mass of the compound. Next, you should calculate the molar mass of particular element. Okay. So, in this manner, if you calculate, you will get the percentage composition. Got it, children? Shall we move to the next one? Good. Next, we can move to formula mass. What is formula mass? Generally, formula mass of an ionic compound is obtained by adding atomic masses of all the atoms. Okay, we have to add the atomic masses of all the atoms in the formula unit of the compound. I'll tell you one example. In the meantime, once again I repeat the definition for formula mass. These are all 2 mark questions, right? So, formula mass of an ionic compound is obtained by adding atomic masses of all the atoms in the formula unit of a compound. Example, we can take sodium chloride. Okay, it is the chemical name of common salt. Okay, here sodium atom, when it reacts with chlorine, sodium Na plus, it is a cation and Cl minus is anion. So, sodium when it reacts with chlorine to form the compound sodium chloride. It is an ionic compound because both it contains positive ion as well as negative ion. Positive ion is Na plus and negative ion is Cl minus. Got it? Right. So, next what we have to do? We have to segregate sodium chloride. So two elements are there. One is sodium, another one is chlorine. So segregate the element first. Sodium chloride. Sodium symbol is Na and for chlorine it is Cl. Okay. Next one. Next we have to know the average atomic mass of sodium and chloride. Okay. Average atomic mass we should know. Right. So next one. What is the atomic mass of chlorine? Chlorine atomic mass is 35.45. Okay. Chlorine atomic mass is 35.45. Right hand side, top side, it is given. Okay. Next one. We have to know the sodium atomic weight. So this is the sodium element. See, its atomic mass is 22.99. Okay. Here it is given 22.99. This is sodium element and this is chloride element. So sodium element atomic mass is AA mass means average atomic mass. It is 22.99 for sodium and 35.45 for chlorine. Next total. Okay, one sodium atom as well as one chlorine atom. So put the number, the same atomic mass here for sodium as well as chlorine. If you add these two, you will be getting 58.44. Now, the formula mass of sodium chloride is 58.44. Is it clear, children? Formula mass means what? Formula mass of an ionic compound is obtained by adding atomic masses of all the atoms. How many atoms are there? One is sodium, another one is chlorine. We have to add the atomic mass of these two elements. The atomic mass of sodium is 22.99. Atomic mass of chlorine is 35.45. If you add these two, you will be getting 58.4. This is the 58.44 is the formula mass of sodium chloride. Clear, children? Next, shall we move to the next one? That is mole concept. Next one is about mole concept. Chemists measure atoms and molecules in moles. So you can understand that mole represents the number of particles. Okay. Mole represents the number of particles. Okay. Mole is defined as amount of substance that contains as many elementary particles. Okay. Mole is defined as amount of substance that contains as many elementary particles as there are atoms in 12 gram of carbon 12 isotope. Okay. In simple form, if you want to explain the mole, 1 mole is equal to 12 gram of carbon isotope. Okay, 12 grams of carbon 12 isotope. 1 mole is equal to 12 grams of carbon isotope. Carbon 12 isotopes. Already I told you about the isotopes. Each and every element has different isotope. Isotope means one or more species which is present in the atom. Right, children? Okay. So this the actual number of atoms can be determined experimentally. Okay. The actual number of atoms can be determined experimentally. It is called Avogadro's number. It is called Avogadro's number. And Avogadro's number is, that is its value is 6.023 into 10 to the power 23 particles. Okay, 6 point, it's a one mark question. 6.023 into 10 to the power 23 particles. So we can understand that 1 mole is equal to 6.023 into 10 to the power 23 particles. Otherwise, 1 mole is equal to 12 grams of carbon 12 isotope. Okay, children? Right. 1 mole is equal to 6.023 into 10 to the power 23. Suppose 1 mole atoms of oxygen is equal to How will you say? The answer is 6.023 into 10 to the power 23 atoms of oxygen. Okay. So 1 mole is equal to, this is very important, one more question. You can expect this question in NEET also. 1 mole is equal to 6.023 into 10 to the power 23 particles. So far we have discussed about law of reciprocal proportion, Gay-Lussac law, followed by some definitions like gram atomic mass, gram molecular mass, formula mass, percentage composition of a compound, formula, mole concept, everything we have discussed, isn't it? Go through everything, children. Today we will get the assignment. Okay, complete all the work, write the answers in a very legible manner. Okay, need write neatly, don't scribble. Leave space for each and every question, right? And next we can see the activity regarding Gay-Lussac's law. Yes, children? Right. Okay, children. Now we are going to do one activity based on Gay-Lussac's law. What is Gay-Lussac's law? Gay-Lussac's law states that at constant volume, the pressure exerted by the gas varies directly with absolute temperature. So this is Gay-Lussac's law. Based on this, we are going to do the activity. So some things are required for this activity. The first one is a plate. Okay. Next one, you need a beaker or otherwise a glass tumbler, right? Next thing is you need some food color. Any food color you can use, orange color or green color, whatever it may be. Next one, a candle is required, matchbox needed, then one spatula for mixing purpose. Okay, and then finally water is required. These things are needed for this activity. So now we can start the activity. First, I am going to add some water into the plate. Right. Next, I am going to add the food color into it. Mix it well. Any food color you can use. Right. Now the water is green in color, isn't it? Right. Next, place the candle at the center of the plate like this. Next, what we have to do? We have to light the candle. Next step, with the help of the beaker or otherwise with this glass tumbler, we have to close the candle, okay, in the inverted position like this. When the flame is burning, the air inside the beaker is heated, okay, because the gas particles expand and they move faster. And it has high pressure. Now observe closely. What do you observe now? Due to lack of oxygen, the flame goes out, isn't it? So when the flame goes out, the temperature decreases and the pressure also decreases. But at the same time, you see the water level. So when the flame goes out, the temperature decreases and the pressure also decreases. Look at the water level now. The water then pulled up to fill in the space inside the beaker. Okay. So what is the concept behind Gay-Lussac law? Gay-Lussac's law states that when the temperature increases, pressure also increases. At the same time, when pressure increases, temperature also increases and vice versa. This is the concept, this is the principle behind the Gay-Lussac's law. Understood, children? Right? Good. Okay, children. Today you will get the assignment, complete it and go through all the laws. Okay, all the laws, and also you work out the problems. Formula you should know for that, and the main thing you should know the atomic mass of some important elements like hydrogen, carbon, oxygen, nitrogen. Okay, so you should know the atomic mass also, then only you can solve the problems. Okay, right. We will see the remaining topics in the next video. Thank you, children.